Dear students, I am Dr. Harold Thomas, Professor in Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya. My today's topic is periodic properties of elements, and in this module, we will discuss about atomic radius, ionization energy, electron affinity, electronegativity, chemical bonding, bond energy, bond length, bond mechanism, type of bond, intramolecular bonds, covalent bonds, ionic bonds, metallic bonds, intermolecular bonds, hydrogen bonds, Wonderwall bonds, and molecular ion attraction. Introduction. Periodic properties of elements. One can observe the certain trends in the periodic properties of elements. These can be understood by analyzing the electron configuration of the elements. The elements tend to gain or lose valency electrons to achieve a stable state configuration similar to the inert or noble gases group 8th of the periodic tables. One can observe the following variations. First, one electron is added moving from left to right across a period. As this happens, the electrons of the outermost cell experience increasingly strong nucleus attraction. Therefore, the electron comes closer to the nucleus and more tightly bound to it. Second, as one moves down a column in the periodic table, the outermost electron becomes less tightly bound to the nucleus. This happens because the sliding of outermost electrons by inner electrons near the nucleus increases. Some of the important properties which I will discuss. First, atomic radius. The atomic radius of an element is half of the distance between the center of the two atoms of the elements which are touching each other. Normally, the atomic radius decreases across a period from left to right and increases down a given group from top to bottom in a group. Moving from left to right across a period, electrons are added one at a time to the outer energy cell. Moving down a group in the periodic table, number of electrons and filled electron cells increases, but the number of valency electrons remain the same. The outermost electrons in a group are exposed to the same effective nuclear charge, but electrons in a group are exposed to the same effective nuclear charge, but electrons are found further from the nucleus. As the number of filled energy cell increase, so the atomic radii increase. Ionization energy. The ionization energy or ionization potential is the energy required to completely remove an electron from a gaseous atom or ion. The more tightly bound an electron is to nucleus, the more difficult it will be to remove and the higher its ionization energy will be. The first ionization energy is the energy required to remove one electron from the parent's atom. The second ionization energy is the energy required to remove a second valence electron from the univariant ions to form the divariant ions, and so on. Successively, the ionization energy increases. The second ionization energy is also higher than the first ionization energy. It increases from left to right across a period, decreasing atomic radius and decreasing down a group, increasing atomic radius. Group 1 elements have lower ionization energy as compared to noble elements. Electron affinities. Electron affinity is the ability of an atom to accept an electron. It is the energy change that occurs when electron is added to a gaseous atom. Atoms with stronger effective nucleus charge have greater electron affinity. The group 2A elements like the alkaline earth have low electron affinities values. These elements are relatively stable because they have filled S subcells. Group 7A elements, that is the halogens, have higher electron affinities because the addition of an electron to an atom result in a completely filled cell. Group 8 elements, noble gases, have electron affinities near 0 since each atom possesses a stable orbit and will not accept an electron readily. Elements of the other group have low electron affinities. Electronegativity. Electronegativity is a measure of the attraction of an atom for the electrons in a chemical bond. Higher the electronegativity of an atom, greater is its attraction for bounding elements. Electrons with low ionization energies have low electronegativities because their nuclei does not exert a strong attractive force on electrons, whereas elements with higher ionization energy have high electronegativities due to strong pull exerted on electrons by the nucleus. In a group, the electronegativity decreases as atomic number increases as a result of increased distance between the valence electrons and nucleus. An example of an electron positivity, that is low electron negativity elements, is cesium, and high electronegativity element is fluorine. Chemical bonding. Chemical bonds is formed to combine atoms. It is an electrostatic force of attraction between areas of positive and negative charge. The location of the areas of charge will differ from system to system. These differences are responsible for the various type of bonds usually found in the compound. There are three types of bonds, namely metallic, ionic, and covalent. The bonds forming process is always exothermic. If two atoms can release energy by forming a bond, then the atoms will be more stable by staying together than they would be as individual atoms. Bond energy. Bond energy is the amount of energy released when a bond forms. It is a direct measure of the amount of stability gained when two atoms establish a chemical bond. The amount that is required to break a bond is exactly equal to the amount released when the bond formed. Bond length. Bond length is the average distance between the centers of the two bounded atoms. The term bond length specifically referred to the average position of the two atoms during the harmonic vibration that they undergo. Bond mechanism. The bond mechanism is an electrostatic force of attraction that hold bonded atoms together. Type of bonds. There are two types of chemical bonds. First, the intramolecular bonds, and the second, intermolecular bonds. Intramolecular bonds refer to the forces of attraction that hold atoms together within a molecules. These type of bonds are considerably stronger than intermolecular bonds. Three types of intramolecular bonds are known, for example, covalent bond, ionic and metallic bonds. On the other hand, the intermolecular bonds refer to the forces of attraction that hold molecules together. This type of bonds are normally weaker. There are mainly three types. For example, hydrogen bond, Wonderwall bonds or Wonderwall forces and molecular ions attraction. Intramolecular bonds, covalent bonds. A covalent bonds is the bond formed by the sharing one, two or three pair of electrons by two atoms. The bonded atoms will experience some level of increased stability as a result of the sharing processes. Atoms attain stability when their outermost energy level are completely filled, that is, they have noble gas configuration. Besides accomplishing it by ionic transfer, this can also be achieved by mutual sharing of electrons. A chlorine atom contains 7 electrons in its third or outermost cell. It can be shown that orbital electrons occur in pairs. In chlorine, we find a pair in the first cell K8 or 4 pairs in second L and third pairs plus 1 add electron in the third cell M. If two Cl atoms could unite to form a molecule of chlorine by sharing 1 electron pairs, the outer cell of each is completely filled. This type of bonding is termed a covalent or homopolar bonds. Properties. Crystal with covalent bondings are electrically insulators in both solid and liquid state. Ionic bonds. An ionic bond is a bond formed by the transfer of one or more electrons from an atom with a low electronegativity to an atom with high electronegativity. The process leads to the formation of cations and anions. Unlike covalent bonds, which creates new orbitals, the ionic bond simply rearrange the electrons within the existing atomic orbits. When NaCl halide is formed by the union of sodium atomic number 11 and chlorine atomic number 17, they combine is brought about by electron transfer, whereby both ions attain noble gas electronic configuration. For Cl atoms, this can be accomplished by adding 1 electron or losing 7. In this electron transfer, the Na atoms becomes a positively charged ions Na+1. The chlorine atoms becomes a negatively charged ions Cl-1. The two oppositely charged particles should attract each other and be held in union by this electrostatic attraction. This type of bonding is called ionic or heteropolar bonds. Properties. Compounds that are bounded ionically have unique general properties. The compounds are poor conductor of heat and electricity. Their solution is good conductor of electricity because their compounds ionize readily. Metallic bonds. In metals, the valency electrons are free to move from ions to ions from the all extensions of the matter. Metal atoms contain few electrons in their valency cells relative to their periods or energy levels. Such electrons can move easily from the atoms and become delocalized, forming a giant lattice of positive ions. Metallic bonds are non-polar because there is no difference among the electronegativity of the atoms participating in the bonding interaction, and the electrons involved in the interaction are delocalized throughout the crystalline structure of the metal. No directional forces are involved and no molecules are formed. Properties: because electrons are free to move from ions to ions throughout a metallic substance, metals are good conductor of electricity and heat and are opaque to light. Intermolecular bonds. Hydrogen bonds. The hydrogen bonds occur between positively charged hydrogen H plus 1 and a negatively charged ions such as oxygen minus 2 or neutron minus 3. The attraction of the partially positive and of one highly polar molecules for the partially negative and of another highly polar molecules is called a hydrogen bonds. Hydrogen has low electronegativity 2.2, and when it is covalently bounded to an atom of fluorine, oxygen or nitrogen, electronegativity of 4.0, 3.5 and 3.1 respectively. The resulting bonds are highly polar. It is found in many phyllosilicates minerals such as clay, micas, chlorite, which contain water in the form of hydroxyl group OH. It is therefore called cation's water. The shape of an H2O molecules is such that it has different charge of its two ends. Water molecules is said to be polar. The H-O-H angle is close to the tetrahedral angle, that is 104 degree. The hydrogen bonds is somewhat weaker than Wonderwall bonds. All molecules exert a weak attraction upon one another. Wonderwall forces are weak attractive forces that hold non-polar molecules together. Such forces are found in non-polar molecules such as hydrogen gas, H2, carbon dioxide and nitrogen, and the noble gases. This attraction is the result of the mutual interaction of the electrons and the nuclei of the molecules. It has its origin in the electrostatic attraction of the nuclei of one molecules for the electrons of another. For example, in graphite, the Wonderwall bonds are responsible for good cleavage and low hardness. Molecular ion attraction. The polar water molecules orients itself so that it's partially positive and faces and negative ions in the same solid. Summary. The course content on the periodic properties of elements begin with the introduction, fundamental of inorganic chemistry, starting with short definition, atomic radius, ionization energy, electron affinity, electronegativity, chemical bonding, bond energy, bond length, bond mechanism, type of bonds, intramolecular bonds, covalent bond, ionic bond, metallic bonds, intermolecular bonds, hydrogen bonds, Wonderwall bonds and molecular ion attraction. For further studies, please read the books and references which are given in the text. Thank you very much.